This is the topic, and what we are going to study, we are going to study what happens when any surface which is submerged inside a fluid. Okay, so what happens, any surface if it is submerged inside the fluid experiences some forces. Okay, whenever we are calculating hydrostatic forces on submerged surfaces, we are considering the fluid to be at rest. So whenever the fluid is at rest, what will happen? No layers will be flowing over another. So इसकी वजह से क्या होता है, जो shear gradient है वो जीरो हो जाएगा. ठीक है, tau will be zero as well as your du over dy. जब ये जीरो होगा तो tau क्या हो जाएगा, जीरो ही हो जाएगा ऑटोमेटिकली. ठीक, सो इस केस के लिए हम क्या करते हैं, we will calculate. So whenever any surface is submerged inside a fluid, suppose this is your any plane surface. Okay, इस plane surface को अब मैं क्या करूँगा, submerge करूँगा. ठीक है, whenever I will submerge this into a tank, suppose एक tank है, water से filled है. इस tank में मैंने इसको क्या कर दिया, submerge कर दिया इस तरह से. ठीक है, तो जब ये इसमें सबमर्ज है तो इसमें क्या होगा कि it is not the fluid layers are not moving, so fluid is at rest. First thing, so ये जो surface है it will experience some force due to this fluid which is surrounding this surface. Okay, so this surface it can be submerged like this. ठीक है, ये इस तरह से भी सबमर्ज हो सकता है. ठीक है, ये इस तरह से सबमर्ज हो सकता है, इस तरह से भी सबमर्ज हो सकता है. ठीक है, या फिर ये इस तरह से भी सबमर्ज हो सकता है. ठीक है, या ये सरफेस कर्व भी हो सकता है. ठीक है, देयर आर सेवरल सिनेरियोस ऑफ दिस प्लेन सरफेस व्हिच इज सबमर्ज्ड इनसाइड द फ्लूइड. ओके, सो इन दिस केस we will calculate hydrostatic forces. In this case we will calculate total pressure and center of pressure. This is the thing that we are going to calculate here. Okay, so before starting this, I will give you a difference between your total pressure and intensity of pressure. Okay, so total pressure and intensity of pressure, इन दोनों के बीच में क्या डिफरेंस होता है? This total pressure is the force, okay, which is exerted at any surface. Okay, so intensity of pressure क्या होता है? It is given by your hydrostatic law, that is P is equal to rho into G into H. This is called intensity of pressure. If I want to calculate the pressure at any point, then I will calculate by using this law. Okay, that is your rho into G into H. This is your hydrostatic law. Okay, but if I want to calculate the total pressure, okay, if I want to calculate the total pressure, then it will be equal to pressure into area. Okay, is it clear? कोई surface है, suppose this is the surface which is submerged inside a fluid. कोई भी fluid है उसके अंदर ये क्या है, submerged. अब इस सरफेस के ऊपर में क्या लगेगा, ये जो फ्लूइड है इट विल एक्सर्ट सम प्रेशर. ठीक है, कोई फोर्स लगेगी. ठीक है, कोई फोर्स लगेगी, उस फोर्स की वजह से क्या होगा, यहाँ पर कुछ प्रेशर होगा. बिकॉज व्हाट इज पी, पी क्या होता है, दैट इज फोर्स पर यूनिट एरिया. कितना फोर्स कितने एरिया के ऊपर में लग रहा है, दैट इज योर प्रेशर. राइट, सो इस सरफेस के ऊपर में कितनी फोर्स लग रही है, so that is represented by F and the area is represented by A. So this will be the intensity of pressure. Okay, so this will be the intensity of pressure. But what I am saying here, total pressure. Total pressure is a force. ये क्या होती है? This is a force. कौन सी force? जिसकी वजह से ये pressure बन रहा है. Okay, so I can say that what will be your total pressure? Total pressure will be this force. Okay, this will be equal to pressure into area. Is that clear? इन दोनों के बीच में डिफरेंस आपको क्लियर होना चाहिए फर्स्ट ऑफ ऑल. ठीक है, सो नाउ so if I will talk about two things here. If I am saying pressure, it means it is due to the I can say that unit weight of the fluid. Okay, unit weight of fluid की वजह से कितना प्रेशर वहां पर लगता है. ठीक है, so it is due to the height, right? P is equal to rho into G into H. But if I am talking about what is the force which is generating this pressure, okay? So what is the force which is generating this pressure? It will be equal to this pressure multiplied by area on which it is. Okay, ठीक है, क्या इसके ऊपर भी ये प्रेशर क्या लग रहा है, जो एक्ट कर रहा है, तो उसके ऊपर में हम क्या कैलकुलेट करेंगे? That will be the intensity of pressure. Is that clear? So from here I can say that what is your total pressure? So total pressure is defined as the force exerted by the static fluid. Okay, the force exerted by the static fluid on the surface. Okay, on any surface, whatever the force which is exerted by your static fluid, that is termed as your total pressure. Okay, so whenever the fluid comes in contact with any surface, it exerts some force on that, and that is termed as, उसे हम क्या कहते हैं? That is your total pressure. Is that clear? Now next one is your center of pressure. What is your center of pressure? Center of pressure means, जैसे कि what is your center of gravity? Center of gravity क्या होता है? Where the whole weight of the body is supposed to concentrate, right? So ये एक body है, ठीक है? इस body का अगर mass m है, ठीक है? तो इसके ऊपर इसका जो weight होगा वो क्या होगा? m into g होगा, ठीक है? m into g, मास के ऊपर जितना भी acceleration due to gravity की वजह से जो फर्क पड़ेगा, that will be mg, right? So अब ये mg जो है ये कहाँ पर एक्ट करता है? हम सपोज करके चलते हैं कि ये कहाँ पर एक्ट करता है, कोई एक पर्टिकुलर पॉइंट होगा where it will act. Okay, so we consider it to be acting at a point which is called your center of gravity. Is that clear? ठीक है, अब अगर इसका जो ये जो बॉडी है, इसका जो वेट है, इट विल ऑलवेज एक्ट डाउनवर्ड्स, राइट? सो इसका जो सेंटर ऑफ ग्रेविटी है वो कभी शिफ्ट नहीं करेगा. इस बॉडी का सेंटर ऑफ ग्रेविटी कभी भी शिफ्ट नहीं करेगा, ठीक है? अनलेस अगर हम इसमें से इसका कोई एक पार्ट यहाँ पर कट ना कर दें. अगर आप इसका पार्ट यहाँ से कट कर दोगे तो क्या होगा? क्वांटिटी ऑफ मैटर वी आर रिड्यूसिंग, राइट? ड्यू टू विच द इफेक्ट ऑफ ग्रेविटी. ओके, सो देयर विल बी चेंज इन द वेट, एंड चेंज इन वेट होगा तो इसकी वजह से इसका जी भी क्या करेगा? शिफ्ट करेगा, अदरवाइज ये शिफ्ट नहीं करेगा, राइट? सो द सेम थिंग हैपेंस whenever the fluid exerts some pressure on any surface. किसी भी सरफेस के ऊपर में क्या कर रहा है? फ्लूइड प्रेशर एक्सर्ट कर रहा है, ठीक है? तो वो जो प्रेशर है, जैसे मैंने ये प्लेन सरफेस कंसीडर किया था, ठीक है? सो लेट अस, इस तरह का मैंने एक प्लेन सरफेस कंसीडर किया, इसके ऊपर में जो फोर्स लग रही है, I am taking it as capital P. So now this is your total pressure, right? Total pressure. So this total pressure is acting on this surface, right? Now I need to calculate at what point on this surface area this total pressure force is acting. Okay? So कौन सा ऐसा पॉइंट है जहां पर ये टोटल प्रेशर फोर्स क्या होगी? एक्ट करेगी. सो अगर इसको हम और कैसे समझ सकते हैं? सो इफ I just divide this area into number of strips, ठीक है? So I can say that at every strip will experience some force, that will be dp, right? कोई प्रेशर फोर्स लगेगी हर एक स्ट्रिप के ऊपर. तो अगर ये छोटे छोटे एरियाज के ऊपर में if I am calculating the total pressure on this small area, so it will be acting on every of the string, right? तो अब सभी के ऊपर में ये जो डीपी प्रेशर है ये लगे जा रहा है, ठीक है। तो इन सभी का जो रिजल्टेंट होगा वो इन सभी का रिजल्टेंट क्या होगा, कैपिटल पी होगा, जो कि पूरे के पूरे एरिया के ऊपर लग रहा है, ठीक है। अब ये जो कैपिटल पी है ये कौन से पॉइंट पर एक्ट करता है, दैट पॉइंट इज टर्म्ड एज योर सेंटर ऑफ pressure. Is the definition of your center of pressure, then it is defined as the point of application of your total pressure, ठीक है। So point of application of total pressure is defined as center of pressure, okay। Now जो submerged surfaces है, we can have different types of submerged surfaces। अब जो submerged surfaces हो सकते हैं वो different type के हो सकते हैं, ठीक है। First one will be vertical surface, vertical surface. Second will be horizontal surface. Third one is inclined surface. Next one is your curved surface. Curved surface. Okay. So we will take one by one all these surfaces and we will calculate what is the total pressure and center of pressure, center of pressure for all these type of surfaces. Is that clear? So, yeah. So first of all, let us take your vertical plane surface. So what will be the topic here? So vertical. So let us consider a vertical plane surface like this. Arbitrary shape में कोई भी एक surface है that I am taking. Okay. ये arbitrary shape why I am taking? This shape can be of rectangular type, right? ये triangular भी हो सकती है, ठीक है? ये circular भी हो सकती है, ये किसी भी तरह की surface हो सकता है, ठीक है? So that's why I am not taking here कोई particular shape नहीं लेकर के चल रहा हूँ. I am just taking it as arbitrary shape, right? So this arbitrary shape is this is your vertical plane. It is submerged inside the fluid, right? It is submerged inside the fluid. Okay. So let us take capital A is the area of this plane surface. Okay. So इस प्लेन सरफेस का कोई ना कोई सेंटर ऑफ ग्रेविटी होगा, इस प्लेन सरफेस का ऑब्वियसली कोई ना कोई क्या होगा, सेंटर ऑफ ग्रेविटी होगा, ठीक है। ये जो सेंटर ऑफ ग्रेविटी है, दिस इज योर फ्री सरफेस ऑफ लिक्विड, यू कैन से दिस इज योर फ्री सरफेस ऑफ लिक्विड. So let us take the depth of your center of gravity from the free surface of liquid is equal to your h bar. Okay, let us take the depth of your center of gravity from the free surface of liquid as h bar. So what is capital A? Capital A is the area of this surface, right? So it is submerged inside a fluid. Now how we are going to calculate, here we are going to calculate what is the total pressure force, or we can say that what is the total pressure which is acting on this surface, ठीक है। अब ये surface तो कैसा है, arbitrary shape है, so let us consider a small strip. इस तरह से हमें कोई small strip लेते हैं which is having your thickness of dh, okay, this is the dh, and let us take the width of this surface as small b, okay. dh is the thickness, this is the small thickness that we are considering here, okay. We will analyze this strip for the force, okay. So the total force, the total pressure which is acting on this strip, we will calculate it first, then we can integrate this area. Okay, अगर हम इस एरिया को इसी नंबर ऑफ स्ट्रिप्स में क्या करें, डिवाइड करते हैं, ठीक है, there will be number of strips. So by integrating that, I can calculate the total force on this whole area. Okay, so I will just consider first of all this small strip. Okay, the distance of this, let us take the distance of this strip from free surface as your h. Okay, intensity of pressure on this small strip, it will be equal to P, small p, it is equal to rho into G into H. So this will be the intensity of pressure that will be on this small strip, right? So now what will be the total pressure, or I can say that pressure force on this small strip? Let us take it as total pressure. Total pressure, it will be equal to pressure into area, right? So pressure into area. Now what is your pressure? Pressure is your rho into G into H. What will be the area of this small strip? It will be equal to dH into d, right? dH into d, that will be the area of this small strip. Now if I want to calculate the total force on this surface, total force on this whole surface, it will be equal to, इसके बराबर हो जाएगा ये, if this is your total pressure force, I can say that this is dF. Okay, so I want to calculate the total force on this. So what I need to do? What I need to do is to integrate this equation to the whole area, right? So I will integrate capital F will be equal to rho into G, इंटीग्रेशन से बाहर आ जाएगा, ठीक है, rho into G, integration of your H into V into dH. Okay, now integration of H into V into dH. Okay, what is your B into dH? What is your B into dH? This is the area of this small strip, right? This is the area of the small strip. So integration of H into, I can write here dA. Now what is your H? What is H? H is the distance of the small strip from the free surface of liquid, and this is area. So H into dA, it will become moment of area. It will become moment of area. This is the area and this is the perpendicular distance. If I multiply area with your perpendicular distance, it becomes your moment of area. Okay, so this is your moment of area of this moment of area about the free surface of liquid, about the free surface of liquid, because the distance of this strip from the free surface of liquid is equal to H, right? So if I am multiplying the area with your H, it will give you the moment of area about the free surface of liquid, right? We have written integration of H into dA, right? So integration of H into dA means if we consider a number of strips like this, अगर हम बहुत सारी ऐसी strips consider करें जिसका जो dH है is the thickness and d is the width. Okay, so I can say that dA is the area, right? अब number of strips I am considering. So what will be the moment of area for every strip? It will be equal to dA into H, right? So area is same. Okay, area क्या रह रहा है? dA is same for every strip, right? So H is changing for every strip, right? H क्या होगा? Change होता जाएगा, ठीक है? तो अगर we have a number of strips, by integrating this we can calculate the moment of area for this whole surface. Okay, so then the moment of area for the whole surface will be equal to, that will be equal to, इसके बराबर में हो जाएगा वो area of surface multiply by area of surface multiply by distance of center of gravity, right? Distance of center of gravity from the free surface of the earth. Okay, so we are taking the integration of h is equal to your h bar. Okay, so we are considering this, right? Is that clear? So it will be equal to area of the surface multiplied by distance of center of gravity from the free surface of liquid. So A into h bar, I can write it here as A into h bar. Okay. So this is the total force which is acting on this vertical surface. Okay. What is the total force which is acting on this vertical plane surface which is submerged inside a static fluid? It is equal to F equal to rho into G into A into h bar. So you need to know about the density of the fluid, acceleration due to gravity, you know what is the area of this plane surface, and what is the distance of center of gravity from the free surface of the liquid, right? So this you need to